Hey guys, so for our last topic in this unit, instead of drawing our own graphs, what we're going to do is we're going to look at a graph and try to go backwards and write its equation. So kind of fun stuff, but it kind of wraps it up really nicely and fills in any kind of like missing things that you might have missed along the way. Okay, so when you're trying to write the equation of a graph, okay, the first thing you always want to start with is identify what it is, okay? It's either going to be a sine or a cosine function, a secant or a cosecant function, or a tangent and a cotangent function. So narrow it down to those choices, okay? How do you narrow that down? Well, let's kind of write a little summary here, okay? So a sine or a cosine function, and these are kind of hard to tell apart, but you guys, these guys are going to be those waves, so they're going to look like this. Okay, those are going to be your sine and cosine functions. Now, the secant, cosecant functions, those are going to be the flips of those waves. So remember, those are going to have those asymptotes, and they are going to look like this. They're going to be the flipped parabolas. Okay, so those are kind of easy to tell apart as well, okay? And then the last thing, you're going to either have the cotangent or the tangent functions. Now, these guys are by far the hardest to tell apart because they look so similar. And you guys, these are also going to have asymptotes, and they're either going to take on this shape or they're going to take on this shape, going up like that. Okay, so just by looking at the shape, you can at least narrow it down to, is it going to be a sine or a cosine, or a secant or a cosecant, or a cotangent tangent? Okay, so you're kind of halfway there. Okay, now, if it's a sine or a cosine, so let's kind of discuss like what we're going to do in each case. Okay, so we're going to first look at sines and cosines, then we're going to look at secants, cosecants, and then we're going to attack these guys, the tangents and the cotangents, because they're a little bit harder. Okay, so if it's a sine or a cosine, so let's look at like example 1, right? Okay, I can, just by looking at the graph, okay, I see a wave, right? I see something that looks like this. It is a wave. That means this is a sine or a cosine function. Now, I don't know what it is yet, okay? And technically, you guys, you can rewrite these as a sine or a cosine function, and depending on how you write it, you can get it right in both cases. So let's kind of look at that as well. So what are we going to do first? Well, the very first thing that you want to do, number 1, and this is super important, okay? We're going to cut the graph in half horizontally and then find the amplitude, okay? This is going to be the A of your function. Now look, I don't really know if it's a sine or a cosine yet, okay? Depending on what I do to it, I can make it either, okay? So how do I cut the graph horizontally in half? Well, if I look at this graph and I think if I drew a horizontal line through there somewhere, where would I draw it so that it would cut it perfectly in half? Well, to me, it looks like right about there, okay? So you guys, this is what I'm going to call my new x-axis. Okay, and check this out. This guy here was your old x-axis. Okay, so let's see what happened here. Okay, so look, I want to find the amplitude of this thing and find the A. Remember, the amplitude is the distance from the x-axis to the highest point or the x-axis to the lowest point, and it has to be the same. But we're going to be using our new x-axis to calculate this, that horizontal line that cut it in half. So let's check it out. If I go from the new x-axis to the highest point, or the new x-axis to the lowest point, how many units did I go? Well, look, here I went up 3, here I went down 3, so that means my A value here is going to be 3. Super cool, right? Okay, so I found 1, woohoo! Okay, now step number 2, okay? Step number 2, and I'm going to try to do this in a different color here. Okay, is to find, actually, I'm going to put it another step right here. Step number 2, I'm going to call it right here. I should have put that in there, gosh dang it. Okay, step number 2 is to determine if it's a sine or a cosine graph. Okay, so here's where I'm going to have to make my choice. Well, if I look at this graph, okay, this is my new x-axis, this guy right here, right? This is still my y-axis, that's still the same. Should not have made that red. And you guys, look where this point is. This is kind of like my new origin, right? Where the new x-axis and the y-axis meet. Okay, what do I know about a graph that starts at the origin and goes up? Okay, what is that? That's a sine graph. And not only is it a sine graph, this is a positive sine graph. Okay, so look, I know that this guy is going to be a positive sine graph with an A that's equal to 3. All right, now the next part, and I kind of got that out of order there. I apologize. Let's do this in a different color, like green. So step number 3 is to find how many complete cycles are there in a period of 2 pi. Okay, now sometimes this is a little bit harder to tell, but we know that we're here dealing with a sine graph. We've just determined that, right? What does the complete cycle of a sine graph look like? Basically, what am I asking is, what does it look like before it starts to repeat? So you guys look, a complete sine graph, okay, is going to start at 0, 0, then it's going to go up, back to 0, and then it's going to go down and back up to 0 again. And at that point, it's going to start repeating itself, right? So I want to look at how many of these shapes can I fit in a period of 2 pi? Well, look, here's 2 pi, right? Okay, I'm going to go and highlight it, okay? So I'm going to start at 0, 0. I'm going to go up, back to 0, and then all the way down and back up to 0 again. And that's where 2 pi completed itself. So how many of these shapes were able to fit in a period of 2 pi? This time, my answer is only 1. I was only to get one of those shapes in there, okay? Now, what does that mean, okay? So find how many complete cycles are there in a period of 2 pi. My answer was 1. This is going to be the value of your b. So in this case, my b is going to equal this nice little one. Okay, so look, I've got my a, I've got my sine, and I've got my b, okay? Now, what else can I do here? Okay, see if there is, let's do a different color still, so step number 4. See if there is a horizontal or a vertical shift. This is going to be your C or your D. Now, you guys, because it started at 0, 0, right, at the origin and then went up, this means that I didn't really move it right or left anywhere, so I'm not going to have a C value this time. It didn't move right or left anywhere. But what about this up and down movement? Now, this one's easier to see, okay? Look. I had an old x-axis, right? That was this guy right here. This was my old x-axis. And then I actually ended up with a new x-axis. That was the one that cut my graph exactly in half, okay? So if I went from my old x-axis to my new x-axis, okay, I had to go up 1, right? So basically I took this whole graph and I pushed the whole thing up 1 unit. So this is going to be the value of my D. Because I moved up 1, this means that the value of my D is also positive 1. Now, putting all of this fun stuff together, let's see what we're going to get. We're going to get y equals, okay? And I'm plugging it into here, into this little template here, okay? My A value was 3, sine of, my B value was 1, okay? And then, remember, that we didn't have a C this time, right? Because it didn't move right or left anywhere, so it's just 1x. You don't have to put a minus anything, okay? And then plus D. My D was 1, so I'm going to put plus 1. And if you want to clean that up a little bit, really, that's going to be the same thing as y equals 3 sine of x plus 1. You don't really need that 1x in there because 1 times x is just x, okay? Now look, I know the first time I do it, it's a little confusing, okay? But it will get easier, I promise, okay? Let's try another one here. Okay, let's look at this one, example 2. All right, so again, I look at this, I see waves, okay? So whenever I see waves, I know this is either going to be sine or a cosine function, okay? So I'm down to those two, all right? So step number 2 is going to be to cut this graph horizontally in half, okay? So kind of imagine if I was to pick a horizontal line and try to cut this graph exactly in half, so the same amounts on top, same amounts on bottom, I think I would say that this right here would be the line. Okay, now you guys, I'm going to call again this my new x-axis. But look here, is it really new? No, it was also the old x-axis. So because the old x-axis and the new x-axis are exactly the same, this means there is no up-down movement at all. There is no up-down movement here. Okay, because we didn't have an axis that had to go all the way up 1 or down 2 or something like that. Okay, so because there's no up-down movement, this time we're not going to have a D value, so we can already cross that off. Okay, now let's look what we've got here. Okay, let's try to find the A value. Remember, the amplitude is the distance from the new x-axis, okay, to the highest point, and the new x-axis to the lowest point. Now, you guys, look, these distances better be exactly the same. If they're not, guess what? you cut it in half wrong, okay? And it's really kind of easy to do, okay? So look, I went up 2 here, I went down 2 here, which means that my A value is a pretty little 2. All right, now, is it a sine or a cosine graph? Okay, well, let's look at the y-axis and see where this guy starts. This guy is starting at a negative amplitude, okay? So you guys, what kind of graph do we have if it starts at negative A and then goes up like this? What is that? It's not a sine function anymore. Remember, sine starts at 0, 0, goes up. Negative sine starts at 0, 0, and goes down. Cosine is the one that's going to start, right, at an amplitude. So this is actually a cosine graph, okay? But because it starts at the negative amplitude, it's actually a negative cosine graph. Interesting, right? So this is going to be a cosine graph, and it's going to be negative. So I'm going to tag a little negative to the A. All right, so let's go ahead and keep putting this together. Now, how do I find my B? So I want to look at how many full cycles of cosine are there in a period of 2 pi. So look, here's 2 pi, and that will always be on your graph, okay? There's 2 pi. So how many full cosines fit in a period of 2 pi? Well, what does a full cycle of cosine look like? Well, I almost drew one here, but you guys look, this guy starts down here, right? And then it goes all the way up, and then it comes all the way back down. And it's at this point that it's going to start repeating itself. Look, it's going to go all the way up, all the way down. Do you see that those are the full cycles of your cosine there? So these are the shapes that you're really looking for. You're going to look at and go, how many of those shapes fit in a period of 2 pi? Well, let's go ahead and draw it, okay? So look, I'm going to go all the way up and then all the way down. There's one, right? So I can do like a little one there. And then look, I could do it again. All the way up, all the way down. Stop, there's 2 pi, right? So how many of those fit in there? You got 2 full cycles of cosine in there this time. So that means that your B value is going to be 2. Now, how about your right and left hand movement? This is all that we're kind of stuck with, right? Again, you guys, because it actually started at an amplitude, it did not have to move right or left. I will show you an example where it moves right or left and it gets a little bit tricky, okay? But this one didn't move right or left anywhere. So let's go ahead and put this in our little template. So we're going to get y equals, the A is negative 2, the trig function is a cosine, the B value is a 2, and then an x. So it's y equals negative 2 cosine of 2x. Remember, there was no up and down movement, no right or left movement, so we don't have to worry about those c's or those d's. Okay, now let's check out some a little bit more interesting ones. Maybe if you want to pause the video and try example number 3 on your own, that might be kind of fun. Okay, so pause. Okay, now unpause. Okay, so let's see how we did. All right, so again, you guys, here, same thing, right? I look at the graph, I see a wave. I know that a wave is going to be either a cosine or a sine graph, okay? How do I figure this out? Well, let's cut it horizontally in half. Now, cutting this one horizontally in half, you're going to end up with this right here. So look, this is my new x-axis. And then this guy right here, this was your old x-axis. Interesting. Okay, now you guys, this time, to get from the old x-axis to the new x-axis, I have to move down 1, 2 units. So I have to move down 2. This means that this whole function was moved down 2, which means that my D is going to be a negative 2. I have to move this down 2, so it's negative 2. Okay, kind of nice, right? All right, now let's figure out the amplitude here. Remember, the amplitude is the distance from the new x-axis to the highest point and the new x-axis to the lowest point. Looking at both of these, we're going up 1, down 1. That means that my A is 1. We can just kind of start filling it in here. So my amplitude is just 1. All right, now to find that B, well, actually let's determine if it's sine or cosine, okay? So look at the new x-axis and look at the old, the original y-axis, right? And you guys look, this function, okay, is actually starting right there at my new origin, right? And it's going down and then up and then down and then up. Who is that? Is that a sine or a cosine? That's definitely a sine function, right? So we know it's a sine function, but you guys, something special here. Remember, a normal positive sine function starts at 0, 0, and goes up. This one started at a new origin and went down. that means this is a negative sine function, which means we need to make the amplitude negative, okay? Now, let's calculate the b here, okay? Now, remember, in the last problem, or the problem before that, I think it was example number 1, we talked about how a full cycle, what a full cycle of sine looks like. So look, one full cycle of sine, or negative sine in this case, is going to go all the way down, back up to 0, all the way up, back down to 0. That's going to be one cycle of sine. And then look, it's going to start repeating itself after that. All the way down, up to 0, all the way up, back down to 0. There's another one. So we're basically looking for how many of these types of shapes are going to fit in a period of 2 pi. Here's 2 pi. I want to stop it right there. Okay, so let's go ahead and highlight. Let's see what this would look like. So look, I'm going to go all the way down, back up to 0, all the way up, back down to 0. There's one. Let's do it again. There's more. All the way down, back up to 0, all the way up, back down to 0. There's 2. Remember, I need to stop here at 2 pi. I can keep going. There's more, right? All the way down, back up to 0, all the way up, back down to 0. There's 3. And stop, right? This is, I hit 2 pi, I'm done, okay? So you guys, how many of those shapes were able to fit in there? We just counted 1, 2, 3 shapes fit in there. So that means that my b value here is going to be 3. 1, 2, 3, okay? Did it move, we already said that it was going to move down 2, so my d is negative 2. Did it move right or left anywhere? Nope. Okay, it started at the 0, 0, no right or left movement. We're good to go, okay? So putting this guy together, we're going to get that y equals, okay, your a equals negative 1. We said that this was a sine function, so sine, okay? We said that our b value was 3, x, and then we said that it moved down 2, so we're going to have a minus 2. And there is the equation of our sine function. Okay, now let's turn it over and look at secants and cosecants. Now, you guys, there's really just like one little extra step you have to do with these, okay? Now, how can I tell, just by looking at example 4 or 5, that these are secants and cosecants? Well, look, the dotted line, okay, this guy right here is just your little template. This truly is not the function, right? Your actual function are these red parabolas, okay? So parabolas, whenever I see these guys, I know right off the bat, hey, this is either a secant or a cosecant function. So look, that's a great way to eliminate stuff, especially if I put it on like a multiple choice test, right? Okay, so how do we start this? Okay, so what you want to do on this is you want to find an equation of its reciprocal function, okay? That's basically the dotted line or the dotted curve. So you want to find an equation for the dotted curve and then just take its reciprocal and you're done, okay? So what we're going to do is we're going to find an equation for this dotted curve that we have here. And we already know how to do that because look, that's just a wave, right? Look, this is just a wave, the blue dotted curve. So I know that's either a sine or a cosine function. Okay, and let's go ahead and split it in half, just like we did before. I'm finding an equation for the dotted one right now, okay? So look, if I were to cut this in half, okay, look, new x-axis is the old x-axis. That means there is no up-down movement. That means there is no d. You don't have to worry about the d, okay? And then let's see if we can find the amplitude here. Remember, the amplitude is the distance from the x-axis to the highest point, distance from the x-axis to the lowest point. In both cases, that's 1. And again, you guys, if you're getting one to be like 1 and the other one to be like 2, it means you didn't draw it right, okay? You got to go back and find where it splits it again, okay? You probably messed up. So if I'm going up 1, down 1, that means my amplitude is a nice 1. Now let's figure out if it's sine or cosine. Well, let's see where this guy is starting. Look, here's your y-axis, right? Okay, this guy is starting not at 0, 0. It's starting at a negative amplitude. So you guys, I know that this is going to be a cosine graph. But not only is it a cosine graph, because it's starting down here and going up and doing this, it's going to be a negative cosine graph. So I know that my amplitude is going to be a negative 1, or my value of a is going to be a negative 1. My amplitude is still 1, right? It's always positive, but my value of a is going to be negative 1. Okay, now let's see how many of these cycles. Remember, one cycle of a negative cosine looks like that. We already kind of talked about it. Let's see how many of these shapes fit into a period of 2 pi. So look, here's 2 pi. I want to stop there and let's go ahead and count. So look, I'm going to start below at the lowest point. I'm going to go to the highest point, back down to the lowest point. There's one full cycle. Let's count again. Highest point, back down to the lowest point. There's another one. Stop. I got to 2 pi. I'm done. So how many of those shapes fit into a period of 2 pi? 2 shapes did. This means that my value of b is going to be a 2. Okay. Now look. There's no up-down movement. We already said that because the old x-axis was the new x-axis. There's also no right and left movement again because it did start on the bottom of the amplitude. It did start right here, so nothing funky with that. So how are we going to put this together? So look, I know that I have a cosine graph, so I'm going to write y equals, the value of a is -1, so I'm going to go -1. I know this is a cosine graph, so it's cosine. Your value of b is 2, so 2x. There's no right, left, no up, down, so I'm done. Now, you guys, look, this, unfortunately, was just the equation for the dotted graph. So I did this. I found the equation for the dotted curve. I don't want that. I want to find the reciprocal function. I want the equation for the red one. So what do? Well, I ask myself, what's the flip of cosine? The flip of cosine is secant. So I'm going to take the flip of cosine and rewrite this and go y equals -1 secant of 2x, and that is my equation, okay? Now, you guys notice the only thing that I flipped was the cosine. I just took the reciprocal of cosine, nothing else. A lot of people think, oh, do I have to flip the whole entire thing, like the 1 and the 2x? No, just the actual trig function, okay? All right, let's try example 3. Wow, this is going to be a really long video. I apologize. All right, so example 3. Again, I see parabolas, right? Whenever I see parabolas, I know that my final answer is either going to be a cosecant or a secant graph. All right, so let's go ahead and start again. My goal is to find the equation of this dotted curve, and then once I have that, I'm just going to take the reciprocal of it and be done. All right, so I need to split this function in half, the dotted curve. To split it in half, this horizontal line here is going to split that in half for me. So this is my new x-axis. This was my old x-axis, right? And you guys notice they're not the same, okay? How did I get from old to new? I had to move down 1. So because I had to move down 1, I know that I have a value of d equal to -1, okay? If you have to move down 2, it'd be -2. If you have to move up 2, it'd be +2, etc., etc. Okay, now let's go ahead and find our little value of a here. Okay, so how far do you have to go from the new x-axis to the highest point, new x-axis to the lowest point? Again, I'm going up 1, down 1, so that means my value of a is going to equal 1. Okay, now, big question here. Is the dotted line here, or the dotted curve, a sine or a cosine graph? Okay, so draw in your y-axis, and let's see what we've got here. Look, here's my new x-axis, my y-axis, right? And look, this dotted graph starts here at a new origin, and then it goes up. Who does that? That's a sine graph, right? So this is a positive sine graph. That's nice to know. Okay, now we need to find out what the value of b is. And you guys, this one's a little bit trickier. Okay, now remember, a full cycle of a sine graph. A sine graph, positive sine graph, starts at 0, 0, goes all the way up, back down to 0, all the way down, back up to 0. This is what one cycle of sine looks like. And then if you wanted to draw another one, you'd be doing this again, right? So I want to see how many of these shapes fit in a period of 2 pi. So I need to stop right there. How many of those shapes fit in a period of 2 pi? Well, let's find out. So I'm just going to start at 0, 0. Going to go all the way to the highest point, then back down to 0. Oh, stop. There's 2 pi, right? It says I just wanted to go to 2 pi. How many of these guys fit in there? Look, not even one whole one, just this part of it. How much of a full cycle of a sine graph fit in there? Only half this time. Isn't that kind of weird, right? So only the top part of there fit in there. So that means that my b value here is going to equal 1/2. Now, you guys, look, I can't give you crazy ones here. I'm not going to give you like 3/4 or something like that for b, okay? 1/2 is probably going to be the grossest thing I'm going to give you, all right? So if my b equals 1/2, let's go ahead and put this guy together. So again, writing the equation for the dotted graph. So the dotted graph here is going to be y equals, the a is 1, it's a sine function. The b is 1/2 x, and then it goes down 1, so it's going to be a -1. Okay, now you guys, technically, I don't really need this one. It's just annoying, so let's go ahead and take it off. So it's sine of 1/2 x minus 1. But you guys, again, this is just a dotted graph. I don't want an equation for the dotted graph. I want an equation for the red graph. So to find an equation for the red graph, I just need to take the reciprocal of that. Okay, what's the flip of sine? I know that the flip of sine is cosecant, so this would be y equals the cosecant of 1/2 x minus 1. All right? Okay, we're almost done. I don't know how long this video is. I'm getting a little bit stressed. All right, tangents and cotangents. Now, you guys, these are a little bit harder, okay, because they pretty much look the same. So you guys, really quick, okay, how do we tell if it's going to be a tangent or a cotangent graph? You're always going to be able to tell which one it is by the placement of the asymptotes, okay? So it might be kind of nice to maybe draw the asymptotes in. So if you look at example 6, like where would these asymptotes be? Well, I think there would be one here, and I would think there would be one there, okay? And you guys remember, a positive cotangent graph always starts here. A positive tangent graph always starts on this side, right? So let's try to figure out what we have here. So based on the asymptotes, remember a tangent graph has an asymptote to the left of the y-axis and to the right of the y-axis. Okay, write this down again in case you forgot. A cotangent graph has an asymptote that is actually on the y-axis, and then it just keeps going on after that. Okay, so which case do we have here? Do we have an asymptote on the y-axis? No, we have one to the left of the y-axis, one to the right of the y-axis. We've got ourselves a tangent graph. Okay, so let's go ahead and write that in because I'm like really excited here. Okay, so we have a tangent graph for sure. Now, is it going to be a positive or a negative tangent graph? I'm not so sure yet. So look at it. Look, a cotangent, a positive cotangent would start on the left. A positive tangent would start on the right. And that's where it's starting. Look, that's where this guy is starting and it's going down like that, right? So I know that I have a positive match there. It is going to be a positive tangent graph. Now, how do you find the A? Well, if I go from the middle point halfway, I could tell that it went up 1. Do you guys see that? If I went halfway to the left, it went down 1. This guy then is the value of your A. So your A equals 1, so you can put like a big fat 1 in there. Okay? Now look, the next thing, and this one's a little bit harder. I have to find out what that value of B is. Okay? Now look, I know that the distance between the asymptotes is the period, okay? So what is the distance between these asymptotes? What's the distance from here all the way to there, okay? Well, look, the distance from here to here, you can't really tell here, but this said negative pi and this said positive pi. So the distance from here to 0 was pi. The distance from 0 to here was also pi. So the whole distance is going to be pi plus pi, which is 2 pi. So I know that the period equals 2 pi. Remember, in a tangent graph, the period is the distance between the asymptotes. Now, how do I calculate the B? Well, look, I know that the period equals pi over B. So look, if the period is pi over B and it's equal to 2 pi, how am I going to solve that equation for B? So look, I can go like this. I can put this over 1. And remember from algebra from a long time ago, you just cross multiply and set them equal to each other. It's just a proportion. So I have pi times 1 is pi equals, and then 2 pi times b is 2 pi b. Remember, I'm solving for b. So I'm going to divide by 2 pi, divide by 2 pi. That's going to give me pi equals, I almost said something else. These cancel out, leaving a 1 on top, so the b is going to equal 1/2. So it's going to be 1 tangent, the b equals 1/2 of x. Okay, and you guys look for the tangent graphs. I'm not going to move them up, down, right, left. It's just too gross. All right, let's try example 7 and then we'll be done. All right, so for example 7, again, I can tell just by looking at these, just because of the little snake shapes, this is going to be either a tangent or a cotangent graph. But how do I tell? The placement of the asymptotes. So let's draw our asymptotes in. You guys, this time looks to me like the asymptotes are going to be like right here and right here. Do you guys see that? You can even draw another one in if you want to. Okay, so look, I'm noticing that, hey, this right here, there's an asymptote on the y-axis, okay? If there's an asymptote on the y-axis, guess what? Asymptote on the y-axis, that's a cotangent graph, okay? So I know that for sure this is going to be a cotangent graph for sure, okay? Is it positive or negative? I don't know that yet, but let's try to see if we can figure it out. Okay, so how do I tell if it's positive or negative? This is how I do it, okay? I know that a positive cotangent starts on the left and a positive tangent starts on the right. Look, you guys, this one is starting right there. Okay, I know it's a cotangent graph for sure, but this doesn't match up. That means that it's a negative cotangent graph. That means that it got flip-flopped, okay? These guys had to get flip-flopped. How do you flip-flop them? By making them negative. Now, what is the value of that A? This one's a little bit harder to tell, but let's see if we can maybe guess, okay? So look, if I cut this in half and try to figure out where it crosses, I think it's going to be down here at -1. Cut that in half, go up 1. It looks like it's going to be here at 1 and -1, okay? So my value of A is -1. And then again, how do I calculate that B? Well, I have to find the period. The period is the distance between the asymptotes. So what's the distance from y = 0 to here? Well, that was pi/2. So the distance from 0 to pi/2 is just pi/2. So I know that my period equals pi/2. I know that my formula for period is pi/b, which has to equal pi/2. And then you guys, you can just cross multiply, or in this case, if you look at it, look, if this is pi and this is pi, then that means that b has to equal 2. And you can cross multiply it if you want to, okay? It'll still come out that b equals 2. So look, your b is 2, so this is cotangent of 2x. And you guys, again, I promise I will not move cotangent and tangent up, down, right, or left. All right? So that's that. I hope you enjoy that. I'm going to go over it in class again tomorrow, but the video's here in case you get confused or want to watch it again. All right? See you guys.